Yeah, the reason that I put these on, 29 to 40, is because it's a way of finding whether a function is one-to-one, meaning it has an inverse, but use the horizontal line test. Don't worry about that other test, the f of a equals f of b. You could use any test you want. That's probably the one you want to do. Right? How can you tell whether, this crazy graph right here passes a horizontal line test? Put it in the calculator and look at it. Right? If I pull up the calculator, let me move this, and let's do that function right there. Y equals x squared divided by parentheses x squared plus 1. And I'll hit the zoom 6. So, does it look like it passed the horizontal line test? What's going on in here right there? My guess is like in between, this is like a horizontal, it looks like a horizontal line. So I don't think that would work. You could zoom in a little bit just to be really looking at what's going on, but does that pass a horizontal line test? No, so it doesn't have an inverse. So we should know how to do that. And then the last part, the 43 through 50 on the same page is here. That's the ones, no, it's actually not the ones we did for homework last night. There. I mean, it's kind of the same thing. I mean, this one said, do it algebraically, check the one-to-one algebraically, and then find the inverse. I had to do the horizontal in that other set of problems, and this one says find the inverse. So you could use those two together to practice this. So again, what are the steps for finding the inverse once you know that it's one-to-one? Right, let's do one of those. So let's say I'll just do for the simplest example. I'll do 43, just to practice those 4 steps. Right. So we would say y, so this is over here. Y equals 2x minus 3. Then what? Switch the x and the y. Then what? Solve for y. X plus 3 equals 2y. Y equals x plus 3 over 2. F to the minus 1 of x equals x plus 3 over 2. Those are the steps. Once you did the one-to-one, like we said before, like we did down here, it gets more tricky when you're doing things like square roots and quadratics because of domain. You got to take into account domain and range. But, what's that? Let's do another one. Let me stop this recording and then we'll do one more, because I think you were gone at your appointment.